So in this video we will discuss about the development of modern periodic table and different parts of modern periodic table. So initially it was Moseley who gave an idea of variation of properties with respect to atomic numbers. So he actually bombarded electrons on metal and he found that frequency relates to atomic number as square root of frequency is proportional to z. So he gave actually the equation square root of frequency is equal to a into z minus b, where a and b are Moseley's constants, which takes into consideration the different aspects of each element. And basically Moseley was studying X-ray diffraction. So he found that the property of element, that is the square root of the X-ray diffracted, varied with certain property other than the atomic mass. So till now, according to the Mendeleev's classification, the concept was that all the properties vary with atomic mass, but he found that some other phenomena governs actually the property of diffracted X-ray radiation. So he gave out this relationship. So after that, modern periodic table and modern periodic law was devised. So modern periodic law, to state, is actually periodic properties of elements are periodic functions of their atomic numbers. So this law was developed based on the experiments conducted by Moseley. So when we say periodicity, what does actually periodicity mean? Periodicity is actually repetition of similar properties of elements after certain regular interval of time. So in periodic table, after regular interval, the properties repeat, and this is actually due to the repetition in similar electronic configuration after regular interval. So periodicity is actually caused by electronic configuration of elements. So because there is a similarity in electronic configuration after regular interval, there is also repetition of properties or periodicity in properties. So the salient features of modern periodic table are like, so if you see features, the first and most important feature is the parts. So it has 7 rows and 18 groups, and shortest period is the first period. Short periods are second and third periods. Long periods are fourth and fifth periods, and longest period is actually sixth one, and incomplete period is seventh period. Similarly, we have different features of groups as well. So we know that first two groups, group 1 and group 2, alkali metals, or you can say alkali metals and alkaline metals, they are basically metals. So they are S block. So we have S block separated. Okay, so they are metals, S block. Then we have group 3 to group 12, transition metals. Then we have group 13 to group 18, P block, or this basically will contain non-metals and metalloids. So actually the modern periodic table which we study is the contribution of Werner and Niels Bohr and Bury. So it's called Bohr's, Bury and Werner's periodic table. So let us see different parts of the periodic table and the properties of those blocks. So first one is actually S block. So if we see for S block, we know that last electron is called a differentiating electron. So for S block elements, all inner shells up to n-1 are completely filled. So inner shells are completely filled here, completely filled, that is n-1th shell. Okay, then differentiating electron enters into new shell and S subshell. So general electronic configuration will be NS1 or 2. So there are only two groups in S block. So this will be general electronic configuration. The metals here are soft and they are extremely electropositive. Then we have very low melting point and boiling point compared to the other metals, because they have very weak metallic bonding because of the less number of valence electrons participating in metallic bonding. They have a fixed valency. So they have a fixed valency. It's also a very important feature, and most of them give color to the flame because the excitation of electron from their valence shell is very easy. Then we have P block. The general electronic configuration for P block is actually noble gas, NS2, NP126. So electrons vary from NS to NP1 to NP6. So the last shell which is going to be filled here is nth shell, and subshell is P. So because P subshell is getting filled from 1 electron to 6 electron, it is kept under P block. So when shells up to n-1 are filled and differentiating electron enters into P subshell of valence shell, then the element is said to be in P block. So this is the definition of P block element. n-1 shell is filled and differentiating electron enters into P subshell of the valence shell. So then only the element is called as a P block element. So this block is a versatile block because it has metals, it has non-metals, it has gases, it has metalloids, like that. And in P block, elements exist in all three states. Elements exist in all three states, and many elements show variable valency and generally they form covalent compounds in p block. And there are different families, like 13th group is called boron family, then 14th group is called carbon family, then we have similarly oxygen family, nitrogen family, halogens and noble gases. So this comprises p block. So next block which you are going to see is d block. So elements in which outermost shell and penultimate shell are incompletely filled and differentiating electron enters into d subshell of the penultimate shell are called d block elements. So here the electronic configuration is ns1 to 2 and n-1 d1 to 10. So even ns0 to 2 we would write, because there is an exception of platinum which has ns0 n-1 d 10. So this is the general electronic configuration. So basically what happens here is the outermost shell, that is valence shell, as well as inner d subshell remains partially filled. So differentiating electron enters into d subshell here, that too inner d shell. That's why it is called d block, and the elements belonging here are d block elements. There are total 10 groups here, that is group 3 to group 12. So total 10 groups, and between S and P block is the D block. They have generally high melting point and boiling point, because they have very high metallic bonding, because there are many n-1 d electrons in each of them, which also participate as valence electrons and participate in metallic bonding. Then most of them are solids except mercury. Then we have the very important properties of these elements, like they act as very good catalysts, they form colored compounds, and they also show variable valency. So these are some of the features of D block elements. Then we have F block. F block elements are also called as rare earth metals, because they are very rare in earth crust. So when outermost, penultimate and anti-penultimate shells are incompletely filled and differentiating electron enters F subshell of anti-penultimate shell, that is n- tooth shell. So if differentiating electron enters into F subshell of n- tooth shell, then the element is said to be F block element. There are two series in F block, lanthanides and actinides. So lanthanides and actinides. So lanthanides are from atomic number 57, it is after lanthanum. Then actinides are after 90, that's thorium. Now we know that there are 14 and 14, total 28 elements in F block. All of them belong to group 3. So group 3. So they all belong to group 3, because both lanthanum and actinium belong to group 3. So if we see their general electronic configuration. General electronic configuration is n minus 2 f1 to 14, n minus 1 d 0 to 2, and ns 1 to 2. So that is the general electronic configuration of F block elements. So they are also metals. They also show variable valency, and they form colored compounds. So let us look into their properties and their behavior in more detail as and when we get into the study of blocks. So this much is the basic information needed for learning modern periodic table. So let us look into the other aspects in next video.